So, gravity methods depend on very much on the density of the rock. If you look at different rock types, right, if you take the first case, unconsolidated sediments, that means not consolidated, right, something like loose sediments. So, their density depend on obviously the composition, what are all the different minerals, what is the porosity, what is the level of saturation. All this is going to influence its density. If you take rocks, sedimentary rocks, what is its composition? Obviously, right, whether it is made up of what element, quartz, feldspar, what is the mineral content, what is its chemical composition, right, and what is its age. As we had seen on the previous page, if the rocks are older, it is expected to have undergone higher degree of compaction. So, density is expected to be more. Then where is it located? If they are at deeper depths, it would have undergone greater compaction, right. And how the grains are binded together, what is the cementation material, right. That means if you take an example of sandstone, sandstone is a typical example for sedimentary rocks. Sandstones are small sand grains binded together with some cementing medium. What is the nature of the cementing medium? Obviously, porosity. What is the saturation, right? All this control the density of sedimentary rocks. Next is the igneous rock, which are the primary rocks, right, which are massive rocks, composition, size of the grains or crystals, fracturing. If the rocks are fractured, it has got higher porosity. When the rocks are fractured, when the porosity is more, density will be less, right. Similarly, for metamorphic rocks, composition, grade of metamorphism, fracturing. In nutshell, the most important thing is the porosity. And what is porosity? Porosity is the ratio of volume, ratio of voids to the total volume, right. If you consider this box of 1 meter dimension, right, here what is the volume of voids? If the volume of voids is 0.2 meter cube, then porosity is 0.2 divided by 1 meter cube. So, it does not have unit, porosity is simply 0.2, right. So, if porosity is higher, then the density will be less, because porosity is a measure of volume of voids, right. And how these voids are filled? Are they filled with fluids? Then density will little bit higher. So, whatever is the rock type, the most important influencing factor for the density is porosity and the fluid that it is filling the pores, right. So, with the help of this, today for example, we are able to understand how the water saturation changes over the surface of the earth, right, at different time periods. We are going to see about this little later. Just to enthuse you, I am showing you this diagram, right, because we had seen on the previous page, porosity and the pore fluid occupying the pores are the important things that control the gravitational pull, right. So, here you can see how the gravity varies over South America in short span of time, right, and a month, every month it varies, right. This is, that is, gravity is converted in terms of equivalent water height. So, it is changing every month. So, this is one of the application of gravitational methods. Now, as we had said previously, gravity depend on the density of rocks. Here is a detail right here, we are showing you the density of air, water, ice, oil, right. So, density of water is given here for some of the important material, and here we can see the comparison between sedimentary, igneous, metamorphic rocks and economic or ore bearing rocks, right. That means sedimentary, what is igneous rocks? Igneous rocks are formed by the eruption of volcano or from molten rocks. When the molten rock cools, it is called as igneous. If that rock undergo without melting, if it undergoes some changes, then they are called as metamorphic rocks. If these rocks undergo a process of erosion, transportation and deposition, then they are called as sedimentary rocks. Right. Among these, sedimentary rocks has comparatively lower density. Then igneous and metamorphic, they are more or less having the same density. Ore bearing rocks has got very high density, right. So, here we can have a look into igneous rocks. These are the different types of igneous rocks. As we have seen there, the density varies between 2.35 to about maximum is 3.5. The same is applicable for metamorphic rocks, right. The lowest value is about 2.5, highest is about 3.54, right. That is what we have given here, right. Metamorphic rock, it is this range, sedimentary rocks in this range, right. This is sedimentary rock, igneous rock. So, if you compare the densities, right, this here I am showing you the density of different sedimentary rocks, except for couple of right, the density is little less, right. Comparatively, if you look at this table, right, where I am marking this red square, very clearly we are able to discriminate sedimentary rocks from the rest of the other rocks. So, from gravity methods, we can distinguish igneous and metamorphic rocks from the sedimentary rocks. Why? Because sedimentary rocks has got lesser density, it is only from 1.5 to 3.3, but density of all the other rocks is around 3 plus. Okay. So, we are able to distinguish sedimentary formation from that of other rocks by gravity surveying. However, it is difficult to, because many rocks has got more or less similar densities. For example, if you see this table, clay and silt more or less the same, soil certainly less, right. Similarly, here if you look into the igneous rocks, most of them are almost close, right, more or less the same range. So, you cannot distinguish whether the rock is granite or andesite. Also difficult to distinguish from gravity survey whether it is granite or basalt, little difficult. Whereas, we are able to quickly differentiate between sediments from that of rocks. So, the gravity measurement depend on variation in the density of rocks present beneath the area of our investigation, right. So, there will be some variation in the density of rocks, as you can see in this table showing the densities of different rocks. even for the same rock it has a big range, right. For example, granite, the density is very expected to vary, lowest can be 2.5, highest can be 2.8. Okay. That depends on how the rock occurs at the site, right. Now, after having seen something in general, let us see about the actual gravity method of exploration, right. What is the principle? Principle of the gravity method of exploration is to understand the subsurface from the variation in the gravity values. That means what? We are going to measure the acceleration due to gravity. The change in the gravity value which we measure is going to help us to understand about the nature of the subsurface. So, the definition of gravity method is to understand, or gravity method is aimed to understand the nature of the subsurface from the variation in the gravity values due to the density of rocks. We have already seen the gravity value can also vary due to latitude, am I right? But here in exploration, we want to make use of the variation in the gravity value due to the density variation, rock density variation, right. How we are going to do? We are going to measuring the acceleration of a body as a result of gravitational force that depend on the density of the underlying rocks. That is what we are going to make use. We had already seen Earth is not a sphere, but it is a flattened sphere, right. So, due to which between the north and south pole radius is, or the diameter is less compared to the equator. In the equator, diameter is greater by about 42 kilometers compared to that between the poles. So, this causes some gravity variation which we are not interested in exploration. We are interested in only understanding the gravity variation due to the change in the density of rocks. That is what we are interested in. For example, here there is a body which is less denser compared to the surroundings. So, when you measure the gravity value is less, right. If I draw a profile, it is something like this. Here the values are lesser. Whereas in this case, you have mass excess, high density. So, when I draw a profile, gravity profile, right, this is the value of G. When I draw the gravity profile is higher above this mass excess. This is the excess mass, above it gravity value is higher. So, this is the principle of gravity method of investigation. Right. What are all the instruments which we are going to use? Right. After having seen the definition, the instruments that are necessary to conduct gravity investigation is, we need a device to measure the gravity. We are going to measure the gravity. So, the device is known as gravimeter. Previously, we had seen resistivity meter. To measure the Earth's resistivity, we had deployed resistivity meter. How did we do? We applied current, measured the potential, using which we determined the apparent resistivity of the subsurface at different depths. Right. Here, to measure the actual acceleration due to gravity, we need an equipment. That equipment is gravimeter. So, we need a gravimeter. A example gravimeter is shown here by this company, right. This is one gravimeter. Apart from gravimeter, we need also some survey equipments. So, why do we need to survey the land, because we want to know the precise latitude, longitude of the locations at which we are going to take the reading of acceleration due to gravity. So, we need to know the latitude and longitude as well as the elevation of the station at which we are going to make the measurement of Earth's gravity, for which you need some survey equipments, right. But nowadays surveying, you need not rely on a total station. As you see in the picture, we can nowadays make use of sophisticated global positioning system to locate the gravity stations. But whatever is the method which you are going to follow, we need to precisely locate the station at which we are going to make the measurement of Earth's gravity. So, simply we need these two equipments. One is we need a gravimeter to measure the acceleration due to gravity. Then we need to survey the land to mark the locations at which gravity measurements have to be taken. Location in the sense we need to know latitude, longitude as well as the elevation, precise elevation. These are all the equipment that are necessary. Now, coming down to gravimeters. We can make use of the gravimeters to measure absolute gravity or relative gravity of the Earth's surface. What do we mean by absolute or relative? In absolute, we are going to measure the actual acceleration due to gravity, right. We had already seen acceleration due to gravity here, right. We had seen acceleration due to gravity here, right, which is nothing but 980 Gal approximately. Depending upon the location, it is going to vary. So, acceleration due to gravity will vary from location to the location. That is what we are going to measure. So, when we are going to measure the acceleration due to gravity, we can either measure the absolute gravity value, that is the first. Let us see absolute gravity measurement. So, here this is the surface of the earth, right. Over the surface of the earth, we will measure at station 1, station 2, like that. We are going to measure whether the value is 980 Gal or 980.1, 982, 983, like that. We are measuring the actual. Here 980.1, here 979.32, here at this place it is 980.19, like that. We are measuring the actual gravity value. This is one way of measurement. In another way, we can just note down the relative gravity values. So, here measurements involve determining the G value at different locations with reference to a base station. We can decide the base station. Let us decide this is the ground surface. I am choosing one station as the base station. Let us take this is the base station for my convenience, right. All of us can choose any station which is of your liking, right. So, in that case, I have chosen this as a base station. What I am going to do here is, I am not going to measure the actual gravity value. I will say, I will calibrate or I will change the reading showing in my gravimeter to 0 at this place. Okay. Now, I shift the gravimeter to this location and trying to find out, I will find out whether the gravity here also 0 or greater or lesser. If it is greater or lesser, how much it is. So, now I am trying to find out. I found out the gravity value here is 0.2 milligauss. That is, when I write 0.02 milligauss, it is greater than this place, right. I am now measuring here. I found out gravity value is minus 0.05 milligauss. That means compared to this station, here the gravity value is less, here the gravity value is more. Here I will write, I will for just for an example, 0.035 minus 0.035. So, when you make measurements like this, then it is called as relative measurements. Okay. So, we have seen two types of measurements. One is absolute gravity measurements, second is the relative gravity measurements. In absolute gravity measurements, we are just taking the actual values. Imagine it is something like this. Now, you are about 20 of you are attending this class. I want to know the height difference among us now. I can either measure the height, we can measure the height of all of us. Height of mine is 170 centimeters, height of you maybe 171, 173, 169, 165, like that we can note down the height of each one of us. That is what is the absolute measurement. In the second case, actually why I am making this measurement? To find out who is the tallest. To find out who is the tallest, why should we measure the height of everyone? Maybe compared to myself, I am 170, compared to myself, name X, height is plus 5 centimeter, Y is minus 5 centimeter. When I note down the height like this, then that measurement is known as relative measurements, right. This measurement can also be converted as relative, isn't it? To convert it as relative, you need a base station. So, for in the case of height, my height was considered as a reference, right. So, survey in the field using gravimeters can be carried out to measure either absolute or relative, right. Now, let us go into the gravimeters. Gravimeters are designed to measure either absolute or relative. First, let us see how we can make the absolute measurements. So, absolute measurement of gravity all of us have done in our maybe in undergraduate or in schools. In plus 2 itself, we have been told about simple pendulum experiment. All of you have measured the absolute gravity in the physics laboratory, right. That is using a simple pendulum. Or we can also determine the absolute gravity, right, absolute acceleration due to gravity by weight dropping method, right, either by simple pendulum or by weight dropping method. In simple pendulum method, right, we attach a pendulum to a thread and determine what is the time period for oscillation. Time period for oscillation is equivalent to this, where L is the length of the thread, that is this, right, and G is the acceleration due to gravity, which is given by this equation, right. So, using the simple pendulum, we can determine the actual or absolute acceleration due to gravity as I was telling you, all of us have determined the absolute gravity using this simple experiment which we had conducted in the physics laboratory. We would have got more or less the same answer, 980 Gal or 980.12, 979.83, like that we would have got some value. So, we can use even simple pendulum. However, simple pendulum may not be accurate, but using simple pendulum we are able to determine the acceleration due to gravity. But in gravity surveying or in gravity exploration, what we are looking for is some small, very small variation in gravity due to the change in the density of rocks. So, simple pendulum may not be sufficient enough to understand the small scale variation. Maybe simple pendulum will be helpful to us if I have drawn like previously, here is gold, here is coal. Over there simple pendulum will show some marginally higher G value. Here it is slightly less G value here. But for practical purpose we cannot use gravity survey by simple pendulum, right. What is the alternative? Next is the weight dropping method. In weight dropping method, we are going to drop a weight from here to here. So, we know the time here and time here, and all using that we can estimate what is the acceleration due to gravity. So, acceleration due to gravity is estimated by noting down the location and from here to here how much time it has taken for this small mass to fall, right. This method is known as weight dropping method. So, here this is the distance and time interval, this is the time here it has reached this location at this particular time. So, using the time interval and the distance between them, we are able to determine the acceleration due to gravity. So, this is done using sophisticated gravimeters as you see in the picture here, right. This is a weight dropping method. That means what is there inside? So, inside there will be a tube, within the tube there will be a small ball. This ball can be lifted up and made to drop from here. As the ball drops at different locations, we sense the time at which the ball has passed. This is something like today in whatever games which we see, right, whether it is tennis or maybe cricket, we also get to know what is the speed at which the ball has traveled, even in shuttle badminton, right. How do they show that? They have some arrangement to determine the location 2. At location 1 what is the time, at location 2 what is the time. In the same way we are able to determine the velocity at which the ball is thrown or hit, isn't it? The same is done here too, right. The difference here is a small mass with a mechanism is lifted up and dropped. The time at which it was dropped is sensed, recorded here, and as it passes through different locations we also note down the time. Using that we determine the mean acceleration due to gravity. So, this is the second method. So, in both the methods, right, one is simple pendulum method, then we had seen weight dropping method. So, these are known as absolute gravity measurements, right. That means in both the cases we have measured the absolute gravity. That means we would have got a value of 981 milligauss, like that, right. So, we had seen already how the gravity value will vary over the surface of the earth, and we had written the acceleration due to gravity already. So, 980 Gauss will be the approximate value of acceleration due to gravity. So, we are able to determine using the instruments, especially the gravity survey, using absolute measurement, right. So, this is how we are able to estimate the value of gravity here too, right, like 981 Gauss or 980.13, like that we are able to measure the actual gravity. So, these equipments are known as absolute gravimeters, right. They are known as absolute gravimeter.